A viewer writes, sometimes I'm watching TV and the phone rings. I run to the phone only to discover that it's not my phone, it's the phone on the TV ringing. Am I losing my mind? Disoriented, Dwight, Ontario. Well, disoriented, you're probably not losing your mind, but chances are that you are disoriented. Us people on TV, you see, have several techniques for fooling your brains. After all, we can convince you that one brand of cat food tastes better than another. Here's the way we make your telephone seem like it's ringing in the other room. I'm going to start by simply making a sound come from behind you. Now, if you hear that tone coming from behind you, it's only because I suggested it was going to. In actual fact, you can't tell where this tone comes from. Normally, we tell the direction of a sound because we have two ears, and the clues to direction come from the relative loudness of the sound at each ear and which ear hears the sound first. Now, there is some concern that human directional hearing falls off with higher frequency sound, but I just fooled you with a tone in your most sensitive range. This is where I run out of research. None of my sources had anything to say about the can't tell where it comes from phenomenon. So either I have here an astounding original theory on hearing perception, or I need a better set of reference books. Here's my theory. Now, among its other tricks, the oscilloscope can present sound waves graphically. Notice how most sounds have lots of personality? A lot of individual wiggles and all different shapes and sizes. Now, have a look at a pure symmetrical sound. This is the one you couldn't identify earlier. Telephone bell has a similar waveform. Now, this is a display of two identical pure sounds, one occurring earlier than the other. On the oscilloscope, earlier is more to the left. Imagine what happens when a pair of ears gets a normal complex sound. The waveform's always changing shape, and it's possible to say which ear is getting the information first and which one's getting the rerun. But look at those pure tones carefully. All right, this one's more to the left, so it's coming first. Or is it? Maybe rather than this piece of the waveform being a little late, it's a lot early. It's impossible to tell. Well, my theory of perception says it's impossible for your brain to use its time cues on a pure symmetrical kind of a sound. Your innocent question has resulted in the Acme theory of sound directional perception and advanced the frontiers of science. Of course, there's always the chance that everyone else already knew this and I'm the last to find out. That's the fun of science.